Okay, welcome to the example section of our introduction on stereophonic microphone arrays. I'm going to illustrate a microphone array for you, and then I'm going to give you an example of what it sounds like. I'll walk from one side of the room to the other. I'll count from 1 to 10. I'll start with 1 on the extreme side of the room, and when I get to the center point of the microphones, the focal point, I'll be at 5, and then I'll be at 10 by the time I get to the other side of your frame. Okay, our first example is an XY pair. An XY pair is made up of 2 cardioid microphones, usually condenser microphones, but there's no rule against that. You could use a dynamic. So a cardioid microphone at 90 degrees angle of incidence, coincident pair. This is an XY pair. I'll start with 1 on your left, move to 10 on your right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's another unique setup. This is a Blumlein pair, so it's another coincident pair. These are condenser figure of 8 microphones, and the top one here is aimed 45 degrees off axis to the left, and this bottom one is aimed 45 degrees off axis to the right. So this will be our left microphone and our right microphone. Don't forget that there's a lobe coming out the back of each of these microphones that is opposite channel from what you have in the front. So if I'm standing here, you're going to hear more out of the left channel, and here you're going to hear more out of the right. But if I'm on the other side of the microphones, now you're going to hear more out of the left and more out of the right. Keep that in mind if you're miking something that has to go in front and behind the microphones. That could have a little bit of interesting quirk to your microphone setup. Okay, so this is the Blumlein pair, and again I'll move left to right, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an ORTF pair. Again, a pair of cardioid. These are condenser microphones. They're angled at 110 degrees to each other and with a spacing of 17 centimeters between the capsules, which makes them a near coincident pair. This is the near coincident ORTF pair, angled cardioid microphones at 110 degrees with a spacing of 17 centimeters, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an example of spaced omnis. So I've got 2 omnidirectional condenser microphones, and they are on a bar, and they're spaced 12 centimeters from the center, which gives us a spacing of 24 centimeters in this particular setup. This is an example of spaced omnis, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since this microphone pair is so sensitive to room reflections, I'm going to give you another example, stepping a little closer to the microphones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a really unique example of spaced omnis. There's an omnidirectional microphone on this side and one on this side, and they're separated by a baffle that's made of wood. So this is the Neumann sphere microphone. Really hard to find a microphone like this, but the idea of having a baffle between 2 omnis is really important, and you might be able to make use of it in a near assignment. This is the baffled spaced omnis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is going to be an interesting experiment to illustrate comb filtering. Right now, if you're listening to this file in stereo, you should be hearing me roughly the same in both channels. And as I move back and forth between one and the other, you should hear my voice probably shift in your stereo image a little bit back and forth between left and right. But if you listen to this in mono, now when I move back and forth between left and right, you should be hearing some really strange flanging effects that occur because of the comb filtering, since we have two microphones in close proximity with each other, having constructive and destructive interference as I move back and forth in and out of their patterns. To illustrate that even more, go back to stereo. Here's a broadband tone that should help to illustrate this really effectively. Stereo. And mono.